Hey guys, so in this video I'm going to discuss some questions on joint continuous random variables, mainly how to calculate the expected value, the conditional expectations and the conditional variances, right? So I'm going to take up two questions and I'm going to solve them. And my next video will also be on the same topic where I discuss some more questions so that the topic gets, solidified in your mind, right? So let's just start now. Hey guys, so this is the first question, right? So let's just solve this now. So first let me write the formula for conditional mean and conditional variance, right? So the formula for conditional mean, if I have two random variables x and y, the formula for conditional mean will be xf x conditional y dx from negative infinity to positive infinity, right? And how do I compute fx conditional y? This is just like how we calculate the probability, the conditional probabilities, right? So this is just the conditional distribution. So let me just show you how do we calculate this. Fx x comma y, which is the joint continuous random variables, the joint continuous probability distribution. So if I take up the case that we have here right now, this is our fx1 comma x2. So and the denominator we have f of y, which is the marginal distribution of y, right? So this is our formula for conditional mean and this is how we compute the fx conditional y, right? So now the variables that we have here in this question is x1 comma x2, right? And fx1 comma x2 is 21x1 square, 21x1 square, x2 cube, right? So in this question what we need to do is we need to find the conditional mean and variance of x1 given x2, right? Where x1 given x2 and x1 and x2 lie between 0 and 1, x1 is less than x2 and x2 lies between 0 and 1, right? So let me just solve this question now. And this is the formula for our conditional mean. This is the formula for our conditional mean, right? So let's just solve the conditional mean first. So let me first compute fx conditional y, right? Or fx1 conditional x2. Because in this question, what do we need to find? We need to find expected value of x1 conditional x2. And what is the formula? The formula will now be x1 into fx1 conditional x2 dx1, where the limits are negative infinity to positive infinity. But we know that the limits in our question, the x1 and x2 lie between 0 and 1, right? So based on that we'll try to find the limits, right? And the limits will be different here, right? Because we are also given one more condition that x1 is less than x2, right? So you can see this here, right? x1 is always less than x2. So let me just solve the question and you will understand what I'm saying. So let me just remove all of this first, right? So let me first compute fx1 conditional x2, and this will be fx1 comma x2 divided by fx2. So for computing fx2, I need to compute find the integral of fx1 comma x2, which is the joint probability function given to us, and I need to integrate this over the limits of x1. So this will be dx1, and the limits of the limits that I'll be taking is, we know that x1 and x2 lie between 0 and 1, and x1 is always less than x2. So my limits for x1 will be 0 to x2, 0 to x2, right? Taking this and this into consideration, my limits will be fx2 0 to x2, and these are the limits for x1. So this will become fx2 will become, I have discussed all of these conditional probability in the previous videos, so you guys can check that out, right? So fx2 will be 21x1 square, x2 cube, 21x1 square, x2 cube, dx1. So dx1. And the limits are 0 to x2. 21x1 squared x2 cube. Yes. So now let me just compute this. F x2 is equal to 0 to x2, 21 x1 square x2 cube, x1 square x2 cube, yeah, dx1, right? So fx2 becomes 21 comes outside, and I'll be treating x2 cube also as a constant, right? So x2 cube also comes out, and this gives me x1 cube divided by 3, 0 to x2, and this becomes 21 x2 cube divided by 3 x2 cube minus 0, and this gives me 7x2 to the power 3 plus 3, 6. 7x2 to the power 6, right? So now my fx1 conditional x2 becomes 21 x1 square x2 cube divided by 7x2 to the power 6, which again gives me 3 x1 square divided by x2 cube, right? So this is my fx1 conditional x2, 3x1 square x2 cube. Now I need to compute my expected value of x1 conditional x2 is equal to x2, which gives me, wait a minute, let me just, yeah, so x1 given, x2 is equal to x2, right? Yeah. So now I need to compute this. So this becomes x1 into 3 x1 square divided by x2 cube dx1, and the limits for x1 are, now the limits for x1 will be 0 to x2, right? Why? Because and, right? So now I'll be treating x2 cube again as a constant. So 3x2 cube, and this gives me x1 cube. So this becomes x1 to the power 4 divided by 4 from 0 to x2, which gives me 3 by x2 cube, and x2 to the power 4 divided by 4, which gives me 3 by 4 x2, right? So this is my expected value of x1 conditional x2 is equal to x2. Right? So this is my value. Now we need to compute. Now the second thing that we need to compute is the variance of x1 conditional x2 is equal to x2, right? Now we need to compute this, right? So for this, for the variance, we know that the variance of x1 conditional x2 will be expected value of x1 square conditional x2 minus expected value of x1 conditional x2 whole square, right? This means that we need to compute this x1 square conditional x2, and for this we need to compute f x1 square conditional x2. And what does this mean? We need to compute f of x1 square comma x2 divided by f of x2. This is wrong. Why? This is wrong. Why? Because the formula never changes. The formula never changes. And what I mean by this is, let me explain to you guys. The expected value of x1 square conditional x2, what will be the formula? The formula will be x1 square. Now f of not x1 square conditional x2, the formula will be x1 square into fx1 conditional x2 only here also, right? dx1. So now we already know fx1 conditional x2 is fx1 conditional x2 is fx1 conditional x2 is, yes, this 3x1 square divided by x2 cube. 3x1 square divided by x2 cube. So this gives me x1 square conditional x2, which gives me integral x1 square 3x1 square divided by x2 cube dx1, and we know that x1 and x2 both lie between 0 and 1, and that x1 is always less than x2, so my limits will be 0 to x2. This gives me 3 by x2 cube comes out, and x1 to the power 4, so x1, if I integrate x1 to the power 4, gives me x1 to the power 5 by 5 from 0 to x2. This gives me 3 by 5 x1 to the power x2 to the power 5 divided by x2 cube, which gives me 3 by 5 x2 square. Now if I just compute variance of x1 conditional x2, my formula is e x1 square conditional x2 minus e of x1 conditional x2 whole square. This gives me variance of x1 conditional x2 as this 3 by 5 x2 square minus 3 by 5 x2 square minus the square of this 3 by 4 x2 minus the square of 3 by 4, wait a minute, the square of 3 by 4 x2, and this gives me 3 by 5 minus 9 by 16, and if I just take x2 square common, this gives me 3 by 5 divided by 16, so 16 into 5 is 80, 16 into 2 16 into 5 is 80, right? Yeah, 50 plus 30, yes, 80. Yes, so 3 into 16 will be 30 plus 6 are 18, 48. So 48 minus 9 5s are 45 divided by 80 and x2 square. So this gives me variance of x1 conditional x2 as, let me go on to the next page, variance of x1 conditional x2 as 3 divided by 80 x2 square, right? 3 by 80 x2 square. This is my variance. Let me just check. 3 by 80 x2 square, and also that x2 lies between 0 and 1, which is given to us. So what we did was absolutely right, and we have found out our answer. So this was the first question that I was just going to discuss, and now that we have discussed this question, I'll be moving on to the second question, right? Right, so let's just start with the second question now. So example 6.36. So example 6.36 says that fx comma y is 2 if x and y lie between 0 and 1 and 0 otherwise. So now we need to show, the first part says that show that expected value of x conditional y equals to y x conditional y equals to y is equal to half of y, right? So this is our first part. Let me just find the solution to the first part, and then I'll discuss the next parts. So the expected value of x conditional y equals to y, this is equal to half of y, right? So the formula for x conditional y will be this x into fx conditional y dx and the limits of x, right? So right now I'm writing the limits as minus infinity to infinity because this is just a general formula. But right now when I'm going to solve the question, the limits will change because I'm already given a constraint that x and y lie between 0 and 1, right? So for solving this, again, like we did in the previous question, first we need to find x conditional y. For finding x conditional y, we need to find fx comma y divided by f of y. Now the formula for f of y we already know, is that take the joint contrast distribution, the joint contrast probability function given to us and integrate it over the limits of x, because we are finding the marginal distribution of y. So now the probability function which is given to us is 2 when x and y both lie between 0 and 1 and x is less than y. This means that our limits will be, so 0x y lie between 0 and 1, and we are also given that x is less than y. This means that our limits for x will be 0 to y. Let me just drop this, 0 to y. Now this means that I have 2 here, right? So 2 0 to y d of x, because this is the marginal distribution of y. That is why we'll integrate it with respect to x. Or if I try to explain it more, if you know about discrete probability, you would know that the formula for f of y is the summation of the probability function. If the probability function is probability of x comma y, then this will be probability of x equals to I comma y, and the limits for I, for example, is negative infinity to positive infinity, so this will be the sum, right, where y is equal to y. So I haven't really discussed about discrete probability. I would take up discrete probability in the next few videos because I really do want to discuss that. If you know discrete probability properly, you can easily figure out what is going on in contrast distributions, right? So I would be taking more and more questions on discrete probability soon, right? So now I have f of y is equal to 0 to y 2 dx. So f of y becomes 2x 0 to y, and this gives me 2 of 2y, right? 2y. So f of y becomes, f of y is 2y. Now I need to compute fx conditional y. Fx conditional y now becomes 2 divided by 2y, which is 1 of y, and I already know that my y lies between 0 and 1, so 0x y then 1 and so now we have our x conditional y, right? Now I need to compute expected value of x conditional y. This what does this mean? X into f of x conditional y, which was 2 upon 2y, which is 1 upon y. So x 1 upon y, and this is dx. Now my limits for x will be 0 to y. Why again? Because right, my limits of x will be 0 to y. So my expected value of x conditional y becomes now y is a constant here, right? So I'll just take out y, and this gives me x square by 2 0 to y, which becomes half 1 upon 2y, and y square, which gives me y by 2, where my y lies between 0 and 1. So this was our ex conditional y. Ex conditional y was yes, half of y. Yes. So our second part says that show that our variances. So this was proven. So show that our variance of x conditional y equals to y is 1 by 12 y square. 1 by 12 y square, right? 1 by 12 y square. So what do we do now? 1 by 12 y square. What do we do now? We would need to compute for variance of x conditional y. We need to compute expected value of x square conditional y minus expected value of x conditional y whole square. Now we need to compute this. So like we did in the previous question, x square conditional y becomes x square. Now f x conditional y only, not x square conditional y, x conditional y only, d of x. And I already know that my x lies between 0 and 1, and it is also less than y. Therefore my limits will be 0 to y, 0 to x, right? Can deduce this from here, right? So my limits for x becomes 0 to y, 0 to y. Now let's just compute this. We have already found out x conditional y was 1 upon y. So this is x square 1 upon y dx from 0 to y. This 1 upon y is a constant, we'll treat it as a constant. X cube by 3, x cube by 3, 0 to y. This gives me 1 by 3y, y cube, y square by 3. I just performed a simple integration. So ex square conditional y becomes y square by 3 and y lies between 0 and 1. Now we need to compute the variance of x conditional y. This becomes y square divided by 3, which is e of x square conditional y. Subtracting from it is the square of expected value of x conditional y. So expected value of x conditional y was y by 2, and the square of it will be y square by 4. So y by 2 whole square, this is y square by 3 minus y square by 4, which is 12. If I take the LCM, 4y square minus 3y square, this gives me y square by 12. And this was what we had to prove, y square by 12. Again, I'll be sharing the working, this PDF of my working with you in the description. Please go out and check this so that if you have any doubts, you can clear them by reading this PDF again. Also, if you find any discrepancy in my work, please let me know in the comments or email me on stats1304@gmail.com, right? stats1304@gmail.com, or put in a comment. It really encourages me if you put in a comment or share the video or like the video, right? So now the third part that we need to find is verify that. So verify that. The C part says that verify that expected value of e of x conditional y equals expected value of x, right? Expected value of expectation of x conditional y is equal to expected value of x. So how will we find this? The expected value of x conditional y is this. Wait a minute. First I need to show you how this formula works, right? Before moving on to solving questions, I need to show you how this formula works. So the expected value of an expectation is equal to the expectation of the first variable here, right? So how does this work? I want to prove that to you guys. So if I take the expected value of an expected value of x conditional y, this is an expected operator, expectation operator only. So how does this work? So we already know that this expected value of x conditional y, is x into f of x conditional y dx, right? From, let's just say, negative infinity to positive infinity, right? Now I need to find the expected value of this. That means that if this function is, for example, g of x, I need to find the expected value of g of x, right? So this means that first of all, let me show you. This means that I need to find the expected value of this whole function, but with respect to what? whenever we write expected value of an conditional expectation, expected value of a conditional expectation, we write it like this. So for example, if I am writing expected value of expectation of x conditional y, this means that I am taking the expectation of x. X conditional y is a function of x, right? And I am taking the expectation of this function with respect to the expected value of y, and this turns out to be the expectation of x. If I am writing expected value of y conditional x, then I'll represent it as expected value of y conditional x, and this will be with respect to x, right? Which will ultimately give me expected value of y only. So now let me just solve this. So this gives me so this is basically this was the function, and I need to take this expectation with respect to y. This gives me negative infinity to positive infinity x f x conditional y dx, and now taking the expectation of this with respect to y gives me expected value from negative infinity to positive infinity f of y, which is the probability function, marginal probability of y, with respect and dy, not with respect to anything, just dy, right? So this is the formula, right? This is the formula. You just have to memorize this formula, right? I tried explaining you guys what this formula means, but you have to open the book first, then only you can understand this formula, right? Let me just duplicate this. So this was our formula. Now let me show you how this equals the expectation of x. So this is x conditional y, and this gives me negative infinity to positive infinity. Now x, this becomes, wait a minute, this becomes negative infinity to positive infinity x fx conditional y, and if I just take fy inside, fy dx dy, this means that what I have is negative infinity to positive infinity and negative infinity to positive infinity x f x comma y upon f of y. So fx conditional y is fx comma y divided by f of y into f of y, and if I just write this as dy dx, this gives me f of y, and f of y gets cancelled. I'm left with negative infinity to positive infinity, negative infinity to positive infinity, f of y and f of y gets cancelled, right? So I'm left with wait a minute, x of x conditional y dy x comma y, yes. So this gives me, now x comes outside, so x comes outside, and I am left with negative infinity to positive infinity, right? And this is fx comma y dy, and let me write dx outside. Now what does this mean? Fx comma y dy, and integrating this with respect to negative infinity to positive infinity. So I'm assuming the limits are negative infinity to positive infinity. Now what does this mean? This is exactly the formula of the marginal distribution of x. What am I doing here? I am integrating the probability function with respect to the y variable, and I'm putting in the limits of y. And what does this give me? This gives me the marginal distribution of x. So f of x is negative infinity to positive infinity f of x comma y d of y. So now what am I left with? I am left with expected value of expectation of x conditional y, and I'm left with negative infinity to positive infinity x, negative infinity to positive infinity f of x conditional y, f of x comma y into d of y d of x, and this is precisely equal to f of x, which means that the expectation of x conditional y gives me negative infinity to positive infinity x of fx dx, which equals as expected value of x, right? So now let us solve this question. I wanted to explain this, how all of this is happening. One, so that you get an idea, you have to open the book. I might not be, smooth enough in my explanation at all times, but if you try to watch this video and supplement this with reading the book and seeing the formula in the book, then it would be really helpful. In my opinion, it will be helpful, right? Otherwise, I'm putting in all of the solutions of the problems that I'm discussing. If you just want to use this channel as watching the solutions and just see the final solution and the method of solving, then that's also fine. It's up to you how to use this channel. Right, so let's just solve the question now. So now we need to verify this, right? So let's just find this now. So our expected value of x conditional y was, our expected value of x conditional y that we found out was in our question, that we found in our question was y by 2. So this was y by 2, this was y, wait a minute, this was y by 2, sorry, this was y by 2. This expected value of x conditional y was y by 2, where y lies between 0 and 1. This was y by 2. Now we need to find the expected value of the conditional distribution x conditional y with respect to y only. So this is e of y, this is e of x. So now we need to compute this. So this is y by 2, and we need to compute the expected value of this with respect to y. So y by 2 f of y dy, and the limits for y are 0 to 1, 0 to 1, right? And f of y, what was the value of f of y? The value of f of y that we computed earlier, was this. Wait a minute, yes, this was 2y, right? So f of y is 2y. So this becomes y by 2, 0 to 1, 2y dy. So 2 and 2 gets cancelled, and this ultimately gives me y square, so y cube by 3, 0 to 1, which means that I have 1 by 3. This is 1 by 3. Now let's just compute expected value of x. So expected value of x will be x of fx dx, and the limits for x are 0 to 1, right? But we haven't computed x. So f of x is, for computing f of x, we need to compute 0 to, so now we need to take the limits of y. So x and y both lie between 0 and 1, and x is always less than y, right? So the limits for y will be 0 to, wait a minute, we are writing the limits for y, right? So for computing the marginal distribution of x, we need to compute the joint probability function, and we need to take the limits of y, right? So fx comma y d of y, and the limits of y will be this, x and 1. So the so y lies between x and 1. So this will be x and this will be 1. I have discussed again how to write the limits in the previous videos. So f of x gives me f of x comma y dy. The limits are x to 1. So now x to 1, and this was 2, and my f of x comma y was 2 dy, and this gives me 2y x to 1. This gives me 2, 1 minus x, and x lies between 0 and 1, right? This was 2. So we have computed f of x, right? So now if I just put this in the formula, 0 to 1, this will become x, and this becomes 2 into 1 minus x dx, right? So let me just move on to the next page. So now the formula for x becomes x into 2, 1 minus x dx. X lies between 0 and 1, so this gives me 2, 0 to 1, x minus x square dx. This gives me 0 to 1, wait a minute, 2 and x square by 2 minus x cube by 3, 0 to 1. Expected value of x finally becomes 6, 1, 1 by 3. So my expected value of x is 1 by 3, and my expected value of x conditional y was expected value of x conditional y was also 1 by 3. So my expected value of x conditional y was also equal to 1 by 3. This means that both are equal to 1 by 3. Hence, we have proven that expected value of x conditional y is equal to expected value of x. Right? Let me just check what we have done is right or wrong. It's right. Expected value of expected value. This is a bit complicated, right? So you need to sometimes read the book and then watch the video, or watch the video and then read the book. Reading the book is quite helpful, but I know for a fact that most of you who are watching this video must be knowing these concepts already and just come to this channel for solving questions. But in case you don't know the concept, please go and watch the video. Go and read the book and then come to this video, or see the video and then read the book. The book is of utmost importance. Everything else, whether it's a video or some other material or some other, or maybe some other PDF or some other text, is completely supplementary. The book needs to be the main focus. The book needs to be used and solved comprehensively so that you know what is happening behind the scenes, right? So thank you for watching this video. If you have made it this far, thank you so much for watching this video. Please share the video, like the video, put in a comment, and do subscribe the channel. It motivates me a lot to keep on coming with new videos, new assignments, new videos, new questions, and new topics to discuss. So thank you so much, and I'll see you in the next video. Bye bye.